Welcome back, everyone. Took a bit of a hiatus. Had some family vacations that kind of took me away from making videos and made it difficult to, coordinate all this stuff. So now that that's over, I'm back to making more videos. So today we're going to be practicing welding some aluminum. So if you watched some of the previous videos, there's some projects that I want to get done that require TIG welding aluminum, and I'm not super experienced with it. I've welded aluminum 6 times ever, and it's always been on the same machine. So tonight I'm going to be trying out welding aluminum with my Eastwood TIG200 AC TIG welder. So first things first, the one thing that I do know about welding aluminum is that you need to be extremely clean. It does not handle contamination well, and it will make your welds look like absolute crap. So what I have to do is I need to swap the belt out on my belt sander. This belt that's on there has only been used for steel and stainless. I don't want to put all that stuff in my aluminum when I sand it, so I need to swap this out for a belt that I'm going to use only for aluminum. So let's get that one done and knocked out of the way. So now with that out of the way, this is what we're actually going to be welding today. So I made these little 2" by 2" square coupons basically on a water jet. So they are incredibly accurate. They have excellent fit up, but I still need to clean these up a little bit. So we will use the belt sander that I just set up along with some Scotch-Brite, which get a new piece every time that you want to do this. Well, at least get a piece that only touched aluminum. And some acetone. Brake cleaner works as well, especially non-chlorinated brake cleaner. If you use chlorinated brake cleaner, just make sure that you let it flash off before you start welding, or you'll be inhaling toxic gas. And then also for this, I have this mix pack of tungsten, and I'm going to be using gray band, which for this particular pack is 2% serrated. This is a fresh piece though, so I'm going to have to put a point on the end of this. But yeah, that's essentially what we are going to be doing. So when I weld aluminum, I like to use steel as a backer. That way I don't end up welding these to this. So I'm going to take a angle grinder with a flap disc on this to clean off some clean area to weld on top of. And then I'm going to clean this up a little bit in the belt sander, and then get to prepping it to get welding. So just to show you guys what I'm doing, I'm taking the oxide layer off of the aluminum with the Scotch-Brite. So you can see how this side is dull. I'm trying not to touch it because I don't want to contaminate it. This is shiny. That's how aluminum oxidizes. Rust is steel oxidizing. The shiny finish is aluminum oxidizing. So cleaned off both sides with the Scotch-Brite, and then I'm just going to go over it with the acetone on a piece of paper towel, and I'm going to try not to touch the section that I've cleaned. And that is the gunk that you take off of dirty aluminum. And that is why you need to do this. So now I'm going to do another piece, that way I have a matching pair to weld to that. And then we'll go over some weld settings and what I'm using to weld. So, like the previous video that I did for the first TIG welds for steel, we are still using my Eastwood TIG200 AC TIG welder. For this, we will be using these settings, at least to start out with, minus this. This should go to AC. So we will use the finger switch on the torch, and then we're going to be at around 65-ish amps. The clearance effect set to -3, the pre-flow to 0.8 seconds, and then the post-flow to 4 seconds. And we're going to see how well that welds. Like I said earlier, I have 2% serrated tungsten in the torch, sharpened to a point. We're going to see if that works out or if it balls immediately, in which case we'll end up balling it. And we're using 1/16 of an inch 40-43 filler rod, because what we were welding up here is 60-61 aluminum. So with all that said, let's finally get around to laying some beads and seeing how well this works. So here's the results of the first attempts. So I welded the seam first, and the first tack that I did, I left the heat too long, so put a hole in it, and then I kept going down the seam, and for whatever reason the arc kept like popping. I don't know if that's because of the steel that I was using as a backer or what the reason was behind that, but you can see like the weld looks kind of dull. Not necessarily a bad thing, just an observation. Got decent penetration through the backside for never trying this before. But what I decided to do was take another run at it, this time without using the steel as a backer, and that is this bead right here, which you can see got shinier. The cleaning action around it is decently even. It's a nice even weld bead as well. I got a little bit of penetration, but not a ton. Yeah, and then just because I played around with the clearance effect just to see if that would help with the arc popping, and that is that bead there over to the side, which you can see it's still shiny. The cleaning action isn't as wide, I feel like, as the other one. I don't know, they're pretty similar, but I did not get as much penetration on the backside with that one. So I'm going to clean up another one of these coupons and weld to this side now and see if I can perfect this a little bit more. So here's the end product. So this is the side that I started on. This is where I finished. I'm not an expert. Obviously, I'm just a hobbyist that does this. Overall, I'm happy with how it came out. I don't think they're perfect by any means. I think I still have a lot to learn before I go embarking on, this huge project. But I'm happy that I did not blow holes through this. I was able to get it to stick together. I don't really know if aluminum welds are supposed to have like penetration on the backside like you would see on a stainless steel or steel weld. Comment below if you happen to be a welder or happen to be a weld instructor or something like that, and let me know if this should be like solid melted together on the backside, because truthfully I don't know. My past experience tells me that it should, but I've never seen it done before on aluminum, so maybe there's a reason behind that. But overall, like, I'm happy with how these came out. They're decently strong. I mean, they're not breaking, so I just bananaed that plate now and they didn't crack apart, so I'll take that as a victory. I wouldn't say that they're going to hold through World War III, but for first time picking up a TIG torch on this machine, I'll take this. So that's gonna wrap up this video. Hope it helped you. If you want to see any of the settings, I'll post them in the description below. That way you don't have to go back through this video and try and find them where I've said them. But yeah, that's gonna wrap this up. So if you made it this far, thank you for watching. Thanks for subscribing, and we'll see everybody next time.